Welcome, everybody. My name is Amit, and I am a principal engineer working with Cisco Meraki. As a matter of fact, I am a colleague of Andre here, and know several of you in this community. So today, I'm going to give a kind of a high-level overview of how we are using Kubeflow in Meraki Vision. So Meraki, to start off, I will explain what Meraki Vision is, and from then onwards, I'll focus on why we needed something like Kubeflow to help us. Okay, so Meraki Vision is a cloud managed smart camera, and they are used for all different kinds of purposes in enterprises, in factories, in outdoor areas, in parking lots, all kinds of places. So it's slightly different from these days. A lot of these vision products have a similar look and feel, and they are very different from how kind of CCTVs used to be, closed circuit TVs used to be there for different departments and enterprises, right? So the basic properties of these kind of smart cameras is that they are very bandwidth conscious. So they use the wide area network bandwidth only when needed. So for example, a Meraki camera uses less than 50 kbps of metadata when footage is not being viewed actually. And as the diagram shows, the camera can you can either watch the stream through local video access, or the stream can be uploaded into the cloud, from which one can do remote video access, right? So all these possibilities are there. So these cameras are bandwidth conscious, and because they have a lot of storage within the camera, so typically in the range of hundreds of gigabytes of storage. So even if there is a network outage, for a certain amount of time, they can record video. And also because the recording is intelligent in the sense that it doesn't just record everything that the camera sees, and instead uses certain kind of filters to record only scenes or portions of the recording, which portions of the stream that are interesting. That's why it can actually keep a history of a large number of hours, even if the network is not up and the camera cannot actually upload the data into the cloud. And as I said, because of the cloud archive options, you can have large amount of data that are archived in the cloud. They're searchable in the cloud, and can do intelligent applications based on this data. Okay. So slowly the intelligence in the camera is increasing, right? When this started, it was not very intelligent. There were only a few minor applications within the camera, and with the boom of these cameras are also increasing. Meraki already has quite a few competitors, and most of these cameras, they kind of, if you look underneath, there is a lot of similarity. And in the recent past, a lot of these cameras are starting to have these edge processing units, which are specifically meant for machine learning applications, such as your tensor processing units, or your NVIDIA has their own units, which are meant for all these edge devices, right? So these edge devices, these edge processing units, they are good for a lot of inference kind of tasks. They are still not that good for training, because training needs a lot of budget, a lot of processing budget. But from a inference point of view, they are pretty good and are commonly being used in these kind of cameras, right? So just as some example use cases within Meraki, and I'm pretty sure most camera companies do this, right? There are things like desk occupancy, right? Monitoring office space usage, and maintaining, given the current pandemic situation, maintaining safe occupancy levels, right? So that's a very common and topical use case. Then there is journey tracking, which is understanding customer and crowd behavior in retail spaces, or even in large companies and enterprises where there is a lot of traffic, right? Foot traffic. And monitoring motion heat maps. So in case of like if you want to monitor a staircase, you want to understand um, how many people, you don't want the exact count, but you just want to see what is the kind of the volume of traffic that's going through the staircase, maybe in normal hours, in case of an emergency, things like that, right? So these are all kind of sample use cases, and I'm pretty sure there are a lot of other use cases which come up once you can do intelligent processing of camera streams. So in Meraki Vision, what we wanted to go ahead and do was we wanted a continuous model training infrastructure. We wanted to build a continuous model training infrastructure to basically enable our developers, right? So before we went ahead and did what I'm going to explain now, there were still models being trained and models being deployed, but it was more or less a manual process, in the sense there was nothing centralized or standardized. Each team was kind of doing its own stuff, and the team was reasonably small, so they didn't have that much of an issue. The number of models being tried were reasonably small. A lot of training was done by maybe third parties, and now as the kind of the use cases are increasing, the number of models that need to be trained are increasing, and the team sizes increase because the product is selling well and stuff like that. So we need developers to be able to access a continuous model training environment, right? So that's where Kubeflow comes into the picture. And since in our team, we had some Kubeflow expertise, Kubeflow was chosen as the option to implement this, right? So just to give a brief overview of where we are using Kubeflow, anyway, for most of the people in this audience, this might be a repetition that you might already know this. So there is the part of data collection and annotation, which then goes to the scalable ML training infrastructure. Once basically the collected and annotated data is fed into this infrastructure. And finally, a trained model is generated, and that model is deployed into in the camera. So we are going to use Kubeflow in basically, just a second. Yeah, so we are going to use the Kubeflow in basically the scalable ML training part and not just Kubeflow, there will be other pieces as well, but Kubeflow is by far the largest component in this, right? So here's a slightly more detailed workflow. So once we have the data collected and annotated, and most companies use some sort of third party for the annotation. You can do a lot of annotation internally, but given the volume, if the volume of data is too high, there are third party companies which allow you to focus your resources on developing models and not on annotation, right? Which is typically very difficult to automate. Right? So then you put this these annotated images in some cloud repository. Here, the example is given of an Amazon S3, but it can work with pretty much any cloud provider. And that's where the interaction with the Kubeflow pipeline starts, right? So basically, the Kubeflow pipeline fetches the data. Then there is the model training, which is unique to each model and the group or the group of engineers who are specifically developing that model. And then finally, some sort of testing, and once the model is accepted, as in its performance is maybe better than the previous run of or previous version of the model, or with a different data set that passes an acceptance test, and it's moved to a repository which contains this camera ready models. And from the camera ready models, there is a different process which takes these models and actually deploys it into the cameras, right? So this is basically the workflow that we were trying to automate. We haven't automated all pieces of it. We are close to that, but a lot of it has been done. And currently we are in the early stages of having a few users using this, and we are probably a few months away from opening this up to larger number of users with larger data sets and with a lot more workloads running. So apart from this generic machine learning pipeline requirements, there were a few other Meraki specific requirements that we had to focus on. And to be frank, these were the requirements which took a lot of our time, because these are specific to Meraki. And even though they are generic in nature, as when I explain, you'll see that most of these requirements are probably true for most enterprises who want to build a system like this. But because the Kubeflow repository and the Kubeflow work primarily focuses on everything entirely open source, there are a few hurdles that we had to face, and those are kind of at the end I will mention the pain points that we had to go through, and not all of them are resolved, but yeah, anyway, I will go over them. So, okay, so for the Meraki specific requirements, we needed GPU enabled infrastructure, and we also needed here I'm saying an EKS deployment, which is the Kubernetes service from Amazon, but it could be any other cloud provider. Why this is so? Because if we wanted to develop something on-prem, then the elasticity is not available. So we would have to provision the servers beforehand. And even though we currently run a lot of our tests on-prem setup, but we know that we cannot really expand it very quickly. So we quickly realized that we needed something running on a cloud provider, right? And definitely we needed GPU support, because without GPU support, it didn't really make sense. The few other things which were very important was that we had to have pretty good interoperability or kind of integration of Kubeflow with things like GitLab, then Artifactory, and Okta. Now, Okta, for people who are not aware, is kind of a what should I say, an authentication system for logging people into the system. So only through your Okta credentials you can access the Kubeflow service. And then with the GitLab service, you can trigger automated runs within Kubeflow. And Artifactory is used for keeping images and whatever Kubeflow usually downloads from the quote-unquote internet in local Artifactory repositories, right? Because as I'll explain later, from a security point of view, most enterprises would not allow downloading stuff from the internet and using it. So these were integrations that we had to work on, and these took us a fair bit of time, and some of them are still ongoing. And finally, even after all these integrations, what we had to focus very heavily on was something called MSDL compliance, which is M stands for Meraki, but it's Secure Development Lifecycle compliance, right? Again, every enterprise has their version of SDL. And so we had to follow all the best practices and make sure that our security group kind of is okay with whatever we are building and signs off on that, because without that, we wouldn't be allowed to run the service. So to give a brief overview on our on-premise ML server where we ran Kubeflow, and we are still running it, and this is where most of our workloads currently are running. And as I said, we are close to opening it up for a larger number of users, and that will be on the cloud. So the ML server that we use was a Cisco UCS C480M5 server. It can have multiple configurations, but the configuration for our servers was each server had 2 Intel Xeon CPUs and 8 NVIDIA V100 GPUs. Right? So these are fairly powerful machines by themselves, but again, given the appetite of the engineers to run ML training, this is nearly not enough. Right? So this is just a kind of a segue into what we were using internally. But now I'm going to talk more about the Kubeflow specific features that we use. So we use all the basic features such as notebooks, pipelines, Katib, and one thing that we were using very heavily was the multi-user capability. But even though the multi-user capability of Kubeflow is somewhat limited, it still is okay for us kind of to use it. It's not the perfect solution, but we can still use it. And we also use KF serving to some extent, where several teams internally need a serving infrastructure. So just to help test their own models. So once they develop a model, they want their own serving infrastructure so that they can themselves test their models with different data sets. Right? So these are primarily the features of Kubeflow that we are using. And I won't go into too much detail into them because most of the people in this community would probably know about this, and these are well documented on the Kubeflow website anyway. So the overall high-level architecture of our system is that a notebook user via a Jupyter notebook installs or runs a workflow instance, which is basically a pipeline. And then we also use a metadata tracking service, which even though Kubeflow provides a metadata tracking service, which is kind of native to Kubeflow, we also use MLflow tracking service because several teams we realize are already using MLflow for tracking the metadata. So we gave an additional option of MLflow, and currently some of the teams are using MLflow to track because they're just used to it. So this is used for tracking your metadata. The pipeline basically runs your training, and then it also accesses your cloud to download the data set, does the training, and can push the trained model into a cloud repository, cloud or even a local repository. It doesn't really matter. That's entirely up to how we want to use it. So I'm going to quickly go over this. These are mostly there so that when you look in the recording, or I can also share the slides if that is needed, that you can have these and look over them. So obviously there are Jupyter notebooks, and as a workflow, I already explained there is simple stuff. You download the data set, you do some training on the data, you do some tuning, hyperparameter tuning with a smaller data set here, and then you do a training with the full data set and do some validation. And for example, here as an example, it showed that you can convert the model into a different model if you want. For example, you might be comfortable coding in a particular format, and then you want to convert it into a different format. All this can be fitted into the workflow. Then we heavily use the pipelines dashboard to figure out what kind of jobs are running and with what kind of scores. So that's something that is very useful to us. And as I said, we use MLflow for tracking the metadata, even though Kubeflow metadata could also be used. But we see that a lot of people are more comfortable with MLflow metadata tracking. Right? So this allows you to log config parameters, data-related metrics, and the runtime metrics. We use for monitoring. We use the hyperparameter tuning monitoring is done by Katib. Additionally, we also use Grafana and Prometheus combination to do the cluster monitoring, such as GPU utilization, memory using memory usage, and typical CPU memory, all those kind of typical stuff. Right? So this is your Katib monitor. This is a snapshot of a of GPU monitoring using Prometheus and Grafana, yeah, again, monitoring the other metrics such as CPU memory, stuff like that. Right? Now let me go over. I'm pretty much close to the end of my talk, but let me go over some pain points that we faced. So most of these pain points are have to do with security, right? So for example, we were not allowed to download public images, so we had to copy over all the public images to local Artifactory. This is a minor issue, but then it is only minor because we are kind of used to the system. So if there is a new user who is not very well conversant with Kubeflow, then maybe some examples on the Kubeflow website where this is specifically taken into account, or even the Kubeflow config taking this into account, saying that, okay, if you have local, then this is how you should configure it. If you want public images, this is how you should configure it. Those might be very helpful. We also saw that there are some default passwords, especially for the MySQL databases that are being used. Now, these default passwords are never allowed. They are like test 1, 2, 3, things like that, right? So these passwords are never allowed by security. So we had to change those passwords. That needed some fiddling around. It would be good to have an automated way to manage these passwords, make them more secure, or basically set your own passwords in whatever secure way you want to use. Then there is the other big hurdle that we are even currently facing is the thing of is the matter of DEX integration. So Kubeflow comes with its own DEX for authentication, whereas most enterprises platforms, like for example the Kubernetes service that Meraki provides us. So Meraki has a Kubernetes service running on some cloud provider, right? So Meraki's security team and IT team, they have their own DEX integration configured already. So we have to kind of configure the DEX within Kubeflow to kind of use the DEX that is provided by the enterprise and not the DEX natively in Kubeflow. So those are things, again, these are all possible, but you would have to try out and kind of trial and error before it will start working, right? So this is a big piece of work that takes up a lot of time. And we haven't successfully done it yet, not because we couldn't, it's just because we haven't gotten around to do it yet. And then there is obviously the release upgrade. So like we are currently on 1.1, we want to go to 1.3, but the upgrade is not easy. It's not smooth. So the upgrades is obviously something that is very relevant to anybody who is using it commercially. So these are the major pain points. And in the immediate future, our target is to, immediate meaning in the next couple months or 3 months or so, we want to upgrade to 1.3, which is a big change because it has a lot of implications for our security clearance, for our MSDL compliance. And hand in hand with the upgrade to 1.3, we want to be completely MSDL compliant because, as you saw, the DEX integration and certain other things are there. For example, we had to move a lot of secrets. We had to move a lot of things from config files to secrets in Artifactory so that things are not visible in config files. And another thing that we are envisioning, apart from the compliance and upgrade, is that we are going to open it up to larger user base. So resource grouping is something that might be an issue. For what I meant by resource grouping is that there will be different teams within Meraki who want to use this infrastructure, right? Right now, given the same Kubeflow infrastructure, given a single Kubeflow infrastructure, we don't have an easy way to say, okay, this particular group of engineers gets, say, 20 GPUs, and this particular group of engineers gets 10 GPUs, something like that. Right now, it is all namespace based on namespace, and each user gets a new namespace, or we can have a namespace for the entire group, but then we lose the identity of the specific user who is running a particular workflow. So there are issues there. We don't have a good solution yet, and this is something that we look into and see how best we can solve it. So this is the immediate future that we have. That's pretty much it for me. So in conclusion, Kubeflow has been very instrumental for continuous model training and developer enablement. People who are using manual training have already moved on to using Kubeflow, so they generally do not have any complaints. They're happy with it. They're using Katib as well. They're using notebooks, pipelines, and basically the architecture that I showed. Right? But we have also seen that there are some issues, mostly around security, that could make things easier for enterprise use case. So these issues, if they're solved, and if a lot more documentation around these issues or kind of example cases around these issues are provided in on the Kubeflow website, then this could ease newer enterprises who want to start using Kubeflow. I know that even within Cisco, there are other teams who are looking at Kubeflow, but they're still kind of very, what should I say? They're very in the very nascent stage, and they really do not understand Kubeflow, and it becomes a big hurdle and an impediment for them to get started. And they tend to continue with doing things manually. So that's about it. If there are questions, let me see if there are questions.
Thank you so much for this great presentation, Amit. There is just one question about the public images. I think it's a very good point. And from my side, I think it's also the question. So do you have any ideas how we can integrate it like in the Kubeflow? Because this is, I think, very important for the different environments.
I really do not know exactly how to integrate it, but see, at the end of the day, it's basically moving over the images to an artifact. So I think most of it can be done through good documentation and maybe some config file changes saying that, hey, if you want to do it through Artifactory, local Artifactory, this is how you should configure. And if you want the public images, this is how you should configure. And I see Patrick is saying that there are tools that can help with the public image thing. It may be what I personally don't know about those tools, so I cannot comment on that.
Yeah, so there's actually two tools that can help with this that I've been playing around with because I ran into this problem too. We can't use public images. So one of them is image package, and image package allows you to kind of like create a package and you can swap out your image registries to something local, so you can do air gapping. Another one was a tool that was a mutating webhook, and that's actually what I'm using now because it's kind of neat and works pretty easy. But it's just a mutating webhook that runs your cluster. So anytime a pod's deployed, it'll look at that pod definition, it'll mutate the image to whatever you basically set up in your map. And that works pretty well. I use that with the Kubeflow deployment just from the manifest repository, and it worked right out of the box.
Okay. Nice.
Could I ask
so maybe,
you, please?
So maybe these things can be taken up. Andre, you can make a note of this and taken up and add it to the documentation, or if some tools need to be packaged in.
Patrick, could I please ask you to create an issue under Kubeflow, because this is related to everything, and just mentioned the working groups.
Yeah, we'll do. Totally.
Yeah, thank you so much. You can just list all of the tools and we can continue our discussion there.
Cool, sounds great. Thanks.
Thank you. Any other questions to Amit regarding to the Meraki presentation and Meraki Vision?
So if there are no questions, just wanted to add that even though we have seen quite a bit of pain points, we do see a lot of whoever has been using Kubeflow within Meraki are quite happy with it because it has really helped them save a lot of time, which they were spending in manually doing things repeatedly. So generally they're happy, but then our view is, or this specific view from Meraki Vision is also somewhat biased because Andre is in our team and we have been working for Kubeflow with Kubeflow for quite a bit of time. We have been contributing to Kubeflow for quite some time. So we are quote unquote experts in Kubeflow. So for enterprises who are new to this, I think their viewpoint might be even more useful because they might be seeing a lot of starting hurdles.
Yeah, exactly. Just one point from my side. I think it would be great that if we can create also like the thread about the security policies and decks and config maps, because this would be, I think, very interesting for the different environments. I don't know, Josh, what do you think about it? Because where we can have this sort of the discussion about the security policies?
That's to me, to Josh.
Yeah, it's like the question to you. I mean, just the place where we can continue our discussion about the problems with the current DEX implementation and the problems about like the password security that Amit pointed before.
Yeah, I think there are two places where maybe those lead into, depending, the security can be big, but maybe the notebooks working group that does some of the authentication work, and then the manifest working group, I think are two places where we might want to bring issues up into those working groups and potentially see if we can find some way to resolve.
Okay, sounds great. So, I mean, could I just ask you, I think we can discuss afterward, but I think we can create an issue and just continue the discussion there.
I think, yeah, so basically the learnings that we had, it would be great for us to contribute back to the community so that these can be smoothened out. Yeah.